Why do most developers write code that looks fast but runs slow? What if I told you that where you place your if statements and your for loops could be the difference between code that crawls and code that flies? After building systems for a long time, I've discovered two simple rules that can transform your code from amateur to professional overnight. And today I'm going to show you exactly how to apply them, and this can be the huge difference between whether your code flies or whether your code crawls. Let's dive into it today. Welcome to Startup Hack. I'm Spencer, and here at Startup Hack, we train software developers in our coding bootcamps as well as build custom software solutions for companies. With a decade of executive leadership as a fractional CTO and 25 years in software development, I've mastered transforming tech teams and products. All right, today we're going to dive into something that separates good developers from great developers. Two fundamental rules about code structure that most people get backwards. This isn't theory, this is battle-tested wisdom from somebody who's refactored more broken code bases than I care to count. Now, your conditional logic or your if code, right, is probably scattered throughout your functions like confetti at a New Year's Eve party. Smart developers move decision-making to the caller instead of burying it inside the function. When I built CleanRouter's content filtering, I learned this in the hard way. Conditions inside of functions create debugging nightmares. Type systems become your friend when you push preconditions to their caller level. So the whole point of this, the simple rule is push ifs up, right? You want to actually find that centralized flow can be pushed toward the top of a method, right? This will come with fewer bugs, cleaner code, and logic that actually makes sense when you read it 6 months later. So why scattered if conditions will kill your performance? If every statement inside of a function is a potential performance killer, and it can be a huge thing that developers ignore. Branch prediction works better when conditional logic is grouped together rather than spread throughout execution paths. So complex branching logic scattered across multiple functions makes optimization nearly impossible for both humans and for compilers. So I've seen code bases where the same condition gets evaluated dozens of different times because it's duplicated everywhere. This dissolving enum pattern shows how pushing conditions up reveals a duplicate logic hiding in plain sight. So again, push your if statement up higher in the code, right? Most programmers think about individual objects when they should be thinking about the collection of objects, right? And this is why data-oriented mindset really can help you shift. Processing data in batches rather than one at a time can deliver performance improvements that seems almost magical. This isn't just about loops. It's about restructuring your mental model of how your program should work. Vector operations and batch processing unlock optimization opportunities that single item processing can never achieve. Modern CPUs are designed for this kind of work, but most code completely ignores these architectural advantages. So when you start thinking about many things at once instead of thinking one time and then change how often it does, right? Now, this comes to where we're talking about loops, right? Putting loops inside of functions instead of outside of them is one of the most common performance mistakes I see. Smart developers write functions that operate on entire collections rather than individual items. This pattern shows up everywhere from jQuery collection to SQL set-based processing. The startup cost of most function calls gets amortized across many operations instead of repeated for each item. Vectorization and SIMD instruction sets can also become possible when you're processing arrays of data together. Even simple changes like this can result in 10x performance improvements without changing algorithms. Now, if your company has systems that need to be optimized, reach out to us, because here at Startup Hack, our specialty is optimizing systems to work like a well-oiled machine. So check out startuphack.com. So the general rule here is what we're going to be talking about is pushing if statements up and for loops down, right? That's where you're really seeing the big rule here. If statements up, for loops down. Because what you want to do is you want to make your for loops as small as possible. What I'll see is I'll see a for loop, I'll open up a function, and I'll see a for loop that's at the top of the function, right? And when you see an example like this, it'll be the for loop, and then it'll be tons of code with hundreds of if statements all throughout. But if you can avoid the for loop altogether and push your if statements up, you can frequently optimize out things instead of having to do them. So let's take a look at an example here of some code really quick to kind of illustrate this. Now, I'm old school, so I still use Sublime Text for a lot of different things here, right? But we're going to go through this bad condition here, right? This bad condition evaluates every iteration, right? So this is the problem, is that you've got your for loop. So let's say you're evaluating some users, right? But you're checking to say if the user is active. Well, you could have actually just filtered out all of the users that were active and then done for loops on them. So this is an example where if you'd push the if up, then we can actually do the process active users here, right? But instead, we're going to loop over every single user and then check to see if this is active. And that's the problem here. So what a good condition can be is say, hey, the users filter and then do the users of just the active users. And then of those, go process these active users. And in this one, do the for loop, right? So this is just a real, and obviously this is an oversimplified example, but I'm just trying to show you this, right? Because the bad version evaluates is active potentially thousands of times unnecessarily. The good version separates filtering from processing, making both operations more efficient. Compilers can optimize the good version in ways that are impossible with the scattered approach. This pattern makes testing easier because you can test filtering and processing logic separately. Modern functional programming languages encourage this style because it leads to more predictable code. Even in imperative languages, this approach reduces cognitive load and potential for errors. So developers often write code that looks efficient but performs terribly because they won't focus on these two fundamental rules: push if statements up and for loops down, right? It's a pretty simple pattern, but it can be really super powerful. Hot paths in applications usually involve processing many similar items, not optimizing single operations. So your brain tricks you into optimizing the wrong things when you think about code line by line instead of flow by flow. Profiling tools will reveal this truth. And AI is a great tool to be able to use to help you with some of these kind of suggestions. But ultimately, some of the AI spaghetti code that it can generate can actually do some of this problem because it's working to try to get it to work rather than focusing on performance, right? So this is where learning, and these are some of the great experience, some of the examples where an experienced developer can learn some of these codes, some of these tricks and spot this really early, right? Now, modern compilers are increasingly sophisticated, but they do need help to do their best work. Loop unswitching and vectorization becomes possible when structured code, when you structure your code to make compiler intentions obvious. Now, if you need some help with your systems to get them optimized and performant, check out startuphack.com/Spencer because we'd love to help. Now, these are just some of the simple practical things we also love to teach here at Startup Hack as we train software developers. So if you're in Utah or Idaho and you're looking for an opportunity to become a software developer, we have a registered apprentice program where we will pay you a training wage for a year to work on real projects. We will train you ourselves and get you up to speed and to work on projects, real world projects, and give you a year's worth of experience. Check out startuphack.com/jobs. So the potential pattern becomes even more important as your system grows and handle larger volume of data. Microservice architectures benefit enormously from this because they can perform really fast and really quick. Database interactions become more efficient when you think in terms of set operations rather than row by row processing. So horizontal scaling becomes easier when your processing logic naturally works with batches of data. So most developers resist these patterns initially because they require thinking about the code structure differently. So again, push your if statement up and your for statements down, your loops down, right? Understanding these principles separate developers who write code from developers who design systems. Technical interviews increasingly focus on architectural thinking rather than algorithmic memorization. Senior engineers' roles require the ability to see performance implications of structural decisions. I frequently will be doing a code review with junior developers and be like, hey, look, if you move this if statement up here instead of out of the for loop, boom, right? So you can see how that can be huge. But it's one of the stuff that people spot all the time. They're like, well, that if statement is expensive. It's right. You're right. It's not. But if you can save yourself some of those loops, that's even cheaper, right? And everything's about cheaper in time, computing resources, or maintainability, right? Because if you're hitting that if statement early, you're not even getting into other parts that could cause problems. Now, what are your thoughts? Do you agree? Do you disagree? I love to have a great discussion, so make sure you leave your comments down below. Here at Startup Hack, we love to train software developers and to build custom software solutions for companies. So reach out, because if you need help, we would love to help you out. Check out startuphack.com/Spencer, and here's some of our services that we offer.
Hi, my name is Spencer Thomason, and I'm a fractional CTO. With over a decade of executive leadership and a solid 25 years in software development, I've mastered the art of transforming technology teams and products. So what is a fractional CTO? This is where you can contract someone like myself to come into your organization and get the benefits of a seasoned CTO without having to employ me full time. In today's fast-paced world, efficiency, security, and product scaling aren't just goals, they're necessities. My passion is building impactful products and enhancing organizational efficiencies through technology. From startups to small businesses, my approach leverages lean methodologies to not just meet but exceed your strategic goals. Whether it's through executive mentoring, cloud system architecture, or launching a minimum viable product swiftly, my aim is to make a significant impact right from the start. Recognized in the Arizona startup ecosystem, my journey has been about creating value and fostering innovation. I have led technology for companies like GoDaddy, SRP, and Wells Fargo and turned challenges into milestones. I've taken this learning and launched 7 of my own brands, and now I want to help you. So if you're looking for a fractional CTO who brings a wealth of experience, strategic vision, and a proven track record, let's connect. Together we can build technology that not only drives your business forward, but also makes a difference. Technology leadership redefined to fit your needs. So reach out today.